Okay, welcome to today's tutorial. My name's Henry, and what we're going to be talking about today is getting a beginner's guide to machine learning for us web developers with ml5.js. And so we're just going to talk about the various ways you can incorporate different machine learning into your projects. We're going to talk about things like transfer learning, we're going to talk about pre-trained models, we're going to talk about transfer learning and custom models, all inside projects so we can see it in action. And one of the biggest motivation for me to really make this tutorial is because for a lot of us web developers, whenever we hear machine learning, it's such an intimidating topic because what pops into our mind is all the mathematics and statistics and all this big brain that has to go into it. And so that's why I picked ml5.js, because it's a nice library that provides that abstraction where we can start integrating machine learning into our projects, without having to learn all of those mathematical statistics, but we can understand the important concepts and the training and the components that go into machine learning. And so ml5.js is often associated with p5.js, which is a way to create art with code. But in our case, because I want you to focus more on the machine learning aspect, we're going to essentially do this in vanilla JavaScript with only the ml5.js library. So in the next session, we're going to essentially talk a little bit of the fundamentals of machine learning and understand the actual training process that goes into it. So I'll see you guys in the next one. Bye. All right, so just a little prereq before we get started. You are going to need to understand the fundamentals of HTML, CSS, and JavaScript and a little interaction with the DOM. And so what you're going to do is you're going to clone this GitHub repo, and it's going to contain the place where we can do our actual practices. So we have the final projects and we have the practice. This is where we're going to mainly work inside here. You can see that we're going to be working with the pre-trained models, transfer learning, custom models of neural networks, and the rock, paper, scissors game with teachable machines. And what you're going to notice is a lot of these projects are already built, but there's going to be certain sections of it, like part 1 and part 2, that we're going to fill in the gaps so we can understand the main components of how we're incorporating that machine learning into our projects. And of course, if you get stuck in any point, we have the final projects. You're going to notice that there's a little bit more projects in final than practice, and that's because there's just some other resources that you guys can look further to explore more, which is the Kaggle and the saving models that we'll briefly talk about towards the end. So anyway, I'll see you guys in the next one, and we'll finally talk about the fundamentals. Okay, welcome to this high review of machine learning, and this is going to set us some foundations as we progress in the ml5.js projects. Okay, so really, let's just jump into it. What is machine learning? Machine learning is really about teaching computers how to spot patterns from massive amount of data so they can make predictions on their own without us having to give them those step-by-step instructions. And so, the way how the machine learns is really these three fundamental parts, right? It makes a guess, and then it compares its guess with the actual answer and sees how far off it was. And based on how far off it was, it's going to optimize its guess and just repeat the cycle so it can make better guesses in the future. And so that was a lot of me saying guess. So let's actually see this in action. What I'm going to do is I'm going to show you a question, and I want you to pause and to just guess the answer. Don't worry if you get it wrong, just guess it. I'm going to repeat this 5 times, and I want you guys to really guess what the pattern is. Okay? So here's the first question. This creature has a blue body and 4 wings and loves to play fetch. What do you think the answer to this is? Blue wings. Okay, second question. This creature has a red body and 2 horns and likes to sleep. What do you think the answer to this is? Red horns. Now at this point, you guys have probably already figured out the patterns, or you feel something is going on with these parts. So question number 3. These creatures has a green body and 6 legs and enjoys running. What do you think the answer to that is? Green legs. This creature has a yellow body and a long tail and likes to jump. What do you think the answer to that is? Yellow tail. Okay. Now finally, this creature has a purple body and sharp claws and loves to climb. What do you think the answer to that is? Purple claws. Okay. So you guys have probably already seen what exactly the pattern is by looking at each of these flashcards, as every time you're iterating towards it. You've actually found out that really what was happening is that we were just really looking at the colors of the body and the actual body parts and just combining them together. And so I want you to really just reflect on your thought process of what actually went into your mind to really solving that. And for a lot of you guys, you guys might be thinking, oh, it's like that 3 steps you just talked about. We made a guess and we compared the actual guess answer with the actual answer, and then we optimized it. And that is true, but I really want you to think a lot more deeper. If you're like me, this might have been your process. Well, the first step, what you did is you essentially identified the features by really breaking down the sentence into individual parts. So the sentence, this creature has a blue body and 4 wings and loves to play fetch. Well, if you look at it, you can see that we actually have 4 features. We have the color, we have the body parts, we have the amount of those body parts, and we have the actual hobbies of that creature. And so step 2 is we essentially evaluated the relevance of each of these features to see which one determined the answer the most. And by doing that, we were basically adjusting the importance by assigning weights to each of these different features to see which priorities of these features should go ahead. And so when we look at this even more deeper, we can think of this in terms of an equation. Right? If we look at this equation, the answer is essentially the color times color weights. Remember the amount of importance it has into the answer. The body parts times the body part weights, and etc. And we came down that for the weights of these, the colors was essentially really relevant, so we gave it a 1. The body part was extremely relevant, so we gave it a 1. But the body parts amounts and the hobbies, they weren't relevant to the actual answers at all, so we just gave them a weight of 0. Of course, this can go between a range from 0 to 1. But at the end of the day, what we found out is that the actual answer was just the color and the body parts. So I want you to really focus on 2 things that I brought up. I talked about features and I talked about weights, right? And these are really important things when it comes into machine learning. What you just saw just now is essentially the way of how machine learning models are created and how they learn. They essentially determine certain features and they basically determine the weights of each of these features to see how important they are to determining the actual probable answer. And so anyway, taking a step back, I want you to really take an appreciation of our brains to do this, right? Our nervous system cells, neurons, are the ones that carry our information to our brains, and we have a network of them to have all this knowledge in our brains and to figure out these patterns. And so really in machine learning, at the end of the day, what we're doing is we're deconstructing the human brain. And so machine learning people, took a lot of inspiration to our neurons, and they created something called neural networks. And don't worry, we're not going to go super detailed into this, but the big idea, and I want you to look really close into it, is you'll start to see a pattern, right? At the end of the day, what we're doing is we're putting some sort of inputs, and it goes through all this magic, which we call a hidden layer, and it comes out with some sort of probable answer. We take our prediction and we compare it with the actual answer, in this case the true value, and then we basically use something called loss function to really objectively measure how far off we were. That goes through a loss score, which goes into an optimizer. And all that optimizer is doing at the end of the day is essentially adjusting those weights. So whenever we make another guess, it's going to make a better guess the next time. And we just keep repeating the cycle. And that's what training is essentially, like what we just did with the flashcards. And so I want you to even think about this, is that whenever we were doing that problem, we were kind of holding some sort of mental equations of features and weights. And at the end of the day, whenever we look into machine learning, it's not magic. It's really just a bunch of mathematics and statistics to really solving a probable answer that we're trying to get out of it. And so yes, we're not going to talk about things like statistics or calculus, like gradient descent. What I really want you guys to understand is the components of machine learning. We're going to talk about data, trainings, and models, and those models that eventually make inference, which we call predictions inside there. And so to see how all of that works together, I'm going to show you guys a cool web application called Teachable Machines, so we can really understand the breakdown of all the components from data to training to model to predictions. So in the next session, we're going to dig into Teachable Machines. I'll see you guys in the next one. Okay, so what exactly is Teachable Machines? Teachable Machines is a great way to really show us the components of machine learning, which is data and the training that we just did just now from the PowerPoints, and then the model that we produced to make a prediction. So I'm going to have you guys have some time to tinker with this later, but the key idea is you're going to click on Get Started, Image Projects, Standard Image Model, and voila. You're going to immediately see that we have 3 components. We have a section where we're going to add the data, we have the training process, and then we have the model that we're going to produce, which is eventually going to make a prediction. And so the key idea of this section over here, the actual data set, is that you're going to essentially upload images, or you're going to upload images and then you're going to label those images. So let's say, for example, you want to do one for cats and dogs. So if I did this one for dogs, I'll upload a bunch of dog photos and then I'll just call this dogs. And then if I have one for cats, I will put a bunch of cat photos and I'll just label this as cats as well too, right? You can put any images. I'm just using dogs and cats as an example. And then you click on training and that's going to produce some sort of model. And so I just got a head start on this. So you can already see I have dogs and I already have cats. And what I'm going to do is I'm going to click on the training, and you're going to see this is going to go pretty quickly. We'll learn why that goes quickly, by the way, later on. Okay, I just said it was going to work quickly and now it's working slow. Oh, there we go. Look at that. Okay. And so immediately right here, the reason it doesn't work is because I'm currently using my camera, but we're not going to need that. What I'm going to do is I'm going to open a file and I'm going to upload an image myself inside here. And you can see I have a bunch of llamas for different projects. But what I'm going to do is I'm going to take this cat photo that I have over here. And then you're going to immediately see that it does a really good guess on it. You can see it says that 99% confident that this is going to be a cat, although it thinks 1% of it is a dog, which is funny. And I think as a result, that just means that you need to just add more data, more quality data, so it can distinguish it a lot more better. But yeah, as you just saw right now, we saw the data aspects, we saw the actual training, which we already saw from the flashcard analogy, and then we see the model inside here. But the cool thing about this with Teachable Machines is that you can actually export your models and integrate it into your projects. So what you're going to see over here is something called TensorFlow.js. TensorFlow.js is a JavaScript library that allows you to build and work on models in JavaScript. In fact, ml5.js is built on top of TensorFlow.js, but ml5.js just has a much more easier interface to interact with. And so one of the things I'm going to do is I'm going to upload my model to the cloud, or you can also download it, which I'll show you guys later. And so we're just going to take a few seconds for this thing to upload. It should be pretty quick. And once I have access to this, I'm going to essentially copy this and I'm going to show you what this looks like. If I go inside here, the file structure in TensorFlow.js file structure is that it looks like this. You're going to essentially have three main components inside your files. You're going to have the model.json, which describes the model architecture. You're going to have the metadata.json, which describes the metadata that's outside the model. So it describes a lot of the labels, such as the cats and dogs that's inside your models. And then remember how I talked about us adjusting weights in machine learning during the training process? Well, then you notice that we have this thing called model.weights.bin, which contains all the weight information. So TensorFlow.js binary file containing the model weights that we're going to be using to do the actual predictions. And so really what we could do is, now that we have access to this file, we can essentially incorporate this into our project and just start using it. And to also just show you really quickly what this looks like in terms of download, if I took this and I downloaded my model and I were to open it like so, you're going to see that we also have 3 files inside here, right? We have the metadata.json, the model.json, which is the architecture, and the weights.bin, and we can just incorporate to our projects. But just for simplicity, we're just going to be doing this on the cloud. So what we're going to be doing in the next session is I'm going to show you how we can incorporate our uploaded link into a rock, paper, scissors games, and we're going to start interacting with good old ml5.js. So I'll see you guys in the next section. All right, so what we're going to be doing is working on our first project, which is this rock, paper, scissors games, and this is going to allow us to incorporate our teachable machine models. So for example, if I say paper and I start round, it looks like I have lost. Okay, let's say that I do rock, I win. So yeah, it's basically going to use our model to distinguish what gesture we pick. So without further ado, let's jump into the code and see how this is going to work. All right, let's have a look at this code. So at this point, you should already download the repo. And so what you're going to go is to practice and to the rock, paper, scissors games. So let me just walk through the code really quickly and then talk about the parts that we're going to add. So inside here, the index.html, you can see that we have our little ml5 CDN. This is going to give us access to the ml5 object to start doing some machine learning inside our projects. You can see this is the video that we're going to be using. This is going to be determining whether or not we pick rock, paper, scissors. This is going to determine whether or not we win, lost, or had a tie. So that's going to display those results. And then we finally have the button, which whenever we click, it's going to have the computer pick something random and compare our gesture with the random gesture it picked. Now in the script.js, you can see down here, this play game is nothing relevant to the AI we're working. It's just a simple function that is going to take our gesture, and it's basically going to randomly pick something of itself, and this is going to determine the logic of whether or not we got a tie, a win, or a loss. The main parts we're going to talk about is this right here. So what you can see over here is that we have a part where we have our model URL. This is where our teachable machine model is going to be going inside. And then you can see we have our classifier that we're going to create, and then we're going to do the prediction inside this function inside here. So let's get started with this. First part is we are going to need to add our model URL. I have already created it, but this is a great time for you guys to start tinkering with teachable machines and seeing how it works. So what you'll be doing is that you can go over to teachable machines. Make sure that you make the labels as these namings: rock, scissors, and papers. So for example, what you do inside here is you can say rock, And then I could use my webcam and basically I'll do something like this, right? And then you'll do that for papers and scissors, and then you'll train the model, and then you can upload that model to the cloud to then take into this project. So going back into this project inside here, right, let's actually talk about the first part that we are going to update. So I'm going to just take this, and you can notice, remember, I am basically targeting that model.json. And this is going to explain the model's architecture. Now for the create image classifier, ml5.js makes this really easy. So we have access to the ml5 object, and what I'm going to say is image classifier. And then what this is going to take is two things. It's going to take the model URL, which is the location of the model itself, and then it's going to have a callback function, which I already created, called model loaded. This basically indicates that the model has finished loading into our project, and then it's going to start the video. So now at this point, it's going to start the video, it's going to turn on, and then we have this function that is actually going to predict or classify our gesture. So what this is going to look like is we're going to be using the variable that we just instantiated, or sorry, the image classifier that we instantiate. So it's going to be called classifier, right, because of this thing right here. Classifier, then .classify, and it's going to take in an HTML element. Because we are going to do it by video, we use the video element that we have inside here. So all I'm going to simply do is inject the video like so. And then I am basically going to, once it classifies the video, it's going to return the results. So it's going to return what exactly the prediction is. And I can show you really quickly what that looks like. So now if I were to go to our projects, you can open this index file manually, but in my case, I have an extension called live server, so I'm just going to open this up. So inside here, if I look and inspect, you see how the video just loaded up, right? So basically, it took a quick picture, and it has this little array of what it thinks. So apparently, my head looks like a rock. So you can see over here that it displays the three predictions, and it shows like the first item in the array is always the highest confidence level that it thinks it is. So you can see that it thinks it's a rock by 99%, and then paper, then scissors. So what we really just need to do at the end of the day is we just need to select the first item of the array and then just get the label to determine that this is a rock. So let's do that really quick in the code. So what I'm going to do inside here is I have this global variable called user choice. And what this is going to allow me to do, I'm just going to set it to that. So I'm going to say results, remember the first item of the array, dot label, and this is going to pick that rock that we just saw from the array. And then I'm just going to say gesture.innerText. This is just going to show in the UI of what gesture we picked. And my gesture is the user choice. And then finally, because we want this thing to constantly repeat, so we want this to continuously keep predicting. Remember, as I was doing my paper and rock and scissors gesture, it was like basically predicting in real time. And to make that consistent, we basically just need to use a recursor function called classify gesture to essentially just keep calling itself. And this is going to have this constantly doing predictions. And that's all we have to do. So now if I go into my code, you should see it should start working now, and immediately it shows my head as a rock. But if I do this, it shows paper. And then you're going to see that I could play the game. Oh, I lost. Let me try again. Okay, I win. Nice, finally. I have to just keep on clicking start round. But yeah, that's basically how we incorporate Teachable Machines model into our projects. But really what we're going to do on from now here is we're going to talk about the 3 ways we can incorporate machine learning into our projects. So this is where we talk about pre-trained models, and then we talk about transfer learning and custom models. So in the next section, we are going to talk about pre-trained models. So I'll see you guys in the next one. All right, so we're finally going to talk about pre-trained models. And so the thing about pre-trained models is that if you remember of Teachable Machines, remember how we essentially had to add our own datas, and then we had to label our datas, and then we had to dedicate some time to training. And even after all of that, our model was only limited to the datas that we trained on, which in this case is dogs and cats. And so this is where a pre-trained model is very useful. A pre-trained model is basically someone that has already trained on lots of different types of data. They already did all the hard work for us, and we can essentially reap the benefits of just using the model they produce into our projects. In this case, Mobilenet is one of the most popular pre-trained models, where essentially it is able to identify thousands of objects from images. And so we're going to quickly see how this is going to work, but you can see in this project, all I'm going to do is I'm going to choose a file, and I could just randomly pick something like this cute dog. And so if I were to open this right here, you can see it classifies it as an Intel Busher. And I actually don't know what that is. So is that okay? Yeah, so that's surprisingly very accurate. It's able to specify the dog breed itself as well. So you can see Mobilenet has been, trained on lots of different types of quality data, and now we can reap the benefits of using it in our projects. So we're going to see how this works in code. All right, so let's go to our next project. You're going to go over to the practice folder, into the pre-trained models folder, and you're going to click on the index.html. So this is actually pretty basic. This is all the line of codes that we're going to work with. But you can see over here that what happens is this is where we upload our files. This is the image that's being displayed, and this is showing the results. And don't forget about your CDN as well for ml5 to get the ml5 object access. And then inside here, whenever we do upload the file, it's going to essentially trigger this load image file. And what this load image file does is it essentially shows the image into our browsers by setting the src, the source file. So if you remember working with images, you need to use src to show, to actually let the image show up. So what we're going to focus on is very similar to what we did in the rock, paper, scissors games. We're going to set up the image classifier, and then we're going to be using it. So let's just get started with this right now. So what I'm going to do inside here is I'm going to say let classifier ml5.image classifier. So it does look familiar. And then instead of actually adding the model URL for Teachable machines, we're going to specify that we're using Mobilenet. So what's really cool about ml5 is that they already have these models integrated into the library that we can use. So I'm going to say Mobilenet, and then I'm going to simply run my callback function load model to indicate that things have finished loading successfully. And it's just going to simply say, yeah, now you can please load a file. And then now all we have to do here is we use it. So it's very similar to the rock, paper, scissors game. So I just say classifier.classify. And so instead of actually adding the video element, we are actually going to be predicting based on the image element itself right here. So that's what I'm going to add. So we basically call this main image. So I'm just going to put that inside here. Main image. And then inside here, I have a, I'm just going to run a callback function inside here, which remember, it's going to return the results. So it's just going to return results like so. And all I'm going to simply say is message.innerHTML is going to equal to the results. Remember, the first item of the results or of that array indicates it has the highest confidence. And I'm just going to display the label like so. So this is all you have to do inside here. So if I were to refresh this and to open up my project now, you're going to see that it should finish loading, hopefully. It says please load a file, which is good. And so what I'm going to do is I'm going to choose a file, and I'm just going to pick the same dog again. And the hope is that it is going to display it as Entlebucher. Nice. Look at that. And that's it. Yeah, you can see now we're able to basically look at different images without having to do the hard work of what we just did in Teachable machines. And I can even choose a file. I will pick, I saw a dinosaur, I'm going to use that one. Yeah, I got this T-Rex, so I'm going to try this one out. Oh, okay, well, right, so this is a perfect example to say that the model isn't, it needs to be trained on more data. Apparently it thinks this T-Rex is a ram. And I think a big reason for that is because this Mobilenet hasn't been trained on dinosaur images like T-Rex inside there, right? But this actually kind of gives us a perfect transition to the topic of transfer learning, which we'll talk about in the next section. So I'll see you guys then. All right, so we're going to finally talk about transfer learning. So let me give you this analogy. So let's say that JavaScript is like your first language. And so as you learn JavaScript, you start to see that there's certain patterns. There's for loops, and there's if statements, and then there's like variables and so on. And so by the time that you want to learn a new programming language after you learn JavaScript, well, then it's so much faster and a lot more easier because you essentially have already know these patterns of for loops and if statements and variables and so on. And so that's essentially what transfer learning is about. Transfer learning is about taking an existing model's knowledge and to really repurposing that to our own specific task. And so one of the things that we are going to repurpose is Mobilenet. So remember how I said Mobilenet has already been trained with lots of high quality data for a long period of time. So it has this knowledge of all these complex patterns and features. So instead of us having to do it completely from scratch and to build this type of knowledge of patterns, well, let's just leverage Mobilenet's patterns to just do for our own specific task. So for example, I want to essentially classify T-Rexes, for example. So instead of me building it completely from scratch, I can essentially just use Mobilenet's knowledge first, build on top of that to get my task completed. So over here, I didn't tell you about this, but Teachable Machines under the hood is using the concept transfer learning. And so you can see over here that with all these images that I put for dogs and cats inside here, these are not the only images that it's using. Remember, it's already has this knowledge because it's using Mobilenet under the hood. It already has all these knowledge of complex patterns, and that's why I don't have to add that much images. And that's why it's able to train significantly faster because it already has these built-in knowledge over these patterns. And so what we're going to do is we're going to essentially build our own our own mini teachable machines. So what I'm going to do here is I'm going to choose some files. You can see I have some llamas. So I want to distinguish between llamas and T-Rexes. So if I were to open this up right here, you're going to see, oops, I got to do inside here. That was the testing one. So I'm going to open inside here, and then I'm going to call this llamas instead. Add the images like so. And then what I'm going to do next is I'm going to choose files for T-Rexes now. 1, 2, 3, 4, 1. Sorry, for 5. And then I'm going to save it for validation testing. Call this T-Rex. Add image. And now I can essentially train the model. And you're going to notice this thing called loss function, or a loss value. And a loss value basically is a way to determine the margin of error from the guess answer that the computer made to the actual answer. So the lower it is, the lower the margin of error that you have, which is a good thing. So what I have over here is essentially a way for me to predict now. So I'm going to essentially take the last image because I didn't test or add that to the data set to test it. So now if I were to predict it, it can guess at 100% that this is a T-Rex. And if I were to choose a file for the llama, for example, I haven't tested this one right here, and I were to say predict, you can see it also thinks 100% that this is also a llama. So that's pretty accurate. And the reason for that is because, again, we are building on top of Mobilenet. So in the next session, I'm going to show you in the code of how we're going to do that. Okay, so let's have a look at this code. So you should have the transfer learning project open. And so you can see we already have the llama and then T-Rex sample image if you guys want to use that. So one of the things you're also going to notice is that we're using an older version of ML5. And the reason is because the latest ML5 took away the feature extractor, which allows us to do transfer learning. So we're just going to use this CDN. So inside here, you're going to see that this is where we upload our files. This is where the images pop up. This indicates messages about how the images are doing. This is how we're going to add labels to the data that we add. And then you're going to notice these 3 buttons, right, that look very similar to Teachable Machines. There's ways to add images, then to train it and to predict it, and these are all going to be connected to ML5 methods to introduce the machine learning process. So if I go over to script.js, and I don't want to overcomplicate this inside here, but the big idea is I made this shorter so you guys don't have to see all the complexities, but essentially all the load image file does is that every time, for every file that I uploaded, it's basically going to have it show up inside the browser. The things that I want you to focus on, and remember, think in terms of Teachable Machines, we have a place for us to add data. So this is where the add image function comes in. We have a place where we basically train our model once we add the data. And then once we have added the data and we trained it, we produce a model, which then is going to do predictions. And that's where all those buttons are connected to, like so. All right, so let's get started with this. So step number 1, as usual, is we need to essentially set up our models, and we're going to be using the feature extractor. So I'm going to be using feature extractor, which is this global variable that I have on the top. And I'm just going to say ml5, and then I'm going to say feature extractor. And so inside here, remember, we basically are using existing models knowledge. So what I'm going to put inside here is Mobilenet. So I need to import Mobilenet inside here as my model, and I need to have it loaded. And then remember, we have our callback function, model loaded. And so what this is going to do is indicate when the model loads successfully, and it's going to set up these event listeners for the button. And then inside here, right, I haven't quite created my classifier, so I'm going to create a classifier. And all I'm going to do is take that feature extractor. Remember, it's just really using, it just loaded the Mobilenet model. And then I'm basically going to say this is going to be for classifications, like so. So that's step number 1. So remember, now we have to add some data. So what this is doing is basically getting the label that was inputted from the users and doing some trimming. And then basically what it's going to do is it's going to take each of those images and add it to that model, or to that feature extractor that we have set up, or the classifier, sorry. So basically what I'm going to do is I'm going to say classifier, and then what I'm going to do inside here is I'm just going to simply say add image. So dot add image. And then I'm basically going to add the image that I have inside here from the files that are uploaded. And then I'm going to associate it to that label that was added by the user, like so. And that's all you have to do. So you basically have your classifier, you add the image, and then you label it. And then finally comes the training model section. And so for the training model, what we're going to do here is we're going to take that same classifier, and then I'm going to say dot train. And what it's going to have is this thing called loss value, which I talked about briefly. But remember, loss value is essentially talking about the margin of error of what the computer has guessed versus the actual answer. So if it has like a very high loss value, it just means that it was completely off from its guess with the actual answer. And so you want to make sure that loss value is as low as possible. So that's something that we can actually check inside here. And I'm going to say if there happens to be a loss value still, then I'm just going to display that. So remember how we were displaying the numbers of the loss, of how it was getting more accurate. So I'm going to say training dot 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 loss, and then I'm just going to simply display the loss value like so. Otherwise, if it doesn't display, once it's done with the loss value and the values are all good, then that indicates that the training is completed. So I just say training complete, like so. And then once I do that, then I can finally do some prediction. So I'm just going to take that predict button that we have created, and then I'm going to set disabled to false. Right, so now we can essentially start using it. So we had added data, we have done the training, and now we finally do the prediction. And at this point, you guys should be pretty familiar with this process. So all we have to do here is we take the classifier, and then we do classify. And then I'm basically going to take the uploaded image, the first item of that array. So I didn't tell you this, but there's this thing called uploaded image. This is what basically contains all of our different files. So the thing is this can only take one image, so I'm only going to select the first one. So I'm going to say uploaded image, take the first one inside there. And so the older versions of ML5 CDN does a different pattern. So instead of us directly returning the results, the first argument is actually an error. And then it finally gives us the results. So just for different shifts of how we do this, we just simply want to say error. If we see error, then we just console that error, the actual error like so. So this is just because this is older version of ML5. And then else, what we're going to do is we're going to say the message that enter HTML is going to equal to the prediction results first item dot label, right? Because this is the results. And we also are going to be showing the results 0. Remember, we have another property called confidence. And I'm going to say to fix, and I only want this to show 2 variables. I meant 2 decimals, so it's not too long. And that's all you have to do, like so. And so now if I were to open my project with live server and to view what this does, you can see model loaded. You can now add images and train. So now I'm going to do the opposite direction. I'm going to take all this, and this. Open that. I'm going to call this llama. And then I'm going to choose one for the dinosaur one, T-Rex. And I'm going to go the opposite direction as well too. 1, 2, 3, 5. Open that, call this T-Rex, like so. And now what I'm going to do is train my model. And you can see that that training loss thing shows up. It says training is complete. So now I'm basically going to take this image and see if it's able to categorize it right. So I'm going to do a predict. Again, it says it with 100% accuracy. And if I go over to the llama and I start with this one right here, and I predict, you can see it also predicts its accuracy as a llama as well too. This is actually super accurate. I think last time when I was testing this thing out, right, it was like saying 77% or something, but I think it's just because I added better quality images. But again, you know, we're basically building on top of existing knowledge from Mobilenet, and that's one of the biggest reasons why our training is a lot more faster and why we don't need as much images. So that's transfer learning. So in the next session, we're going to talk about custom models. I'll see you guys in the next one. Okay, so briefly, I want to talk about a common misconception people have with transfer learning. So here's another analogy, right? Let's say that your first language was JavaScript and now you know Python, but in your company, they only want you to program in Python. Because you're only programming in Python and you're not practicing your JavaScript, you're going to forget your JavaScript. Right? And so in order for you to get good at both of those languages, you're going to need to have some dedicated time to practice or train on these two languages so you don't forget about it. And so this applies to transfer learning as well too, right? So the thing about Mobilenet is that it's been trained to be able to identify thousands of different types of images. But remember, we took Mobilenet, this existing model, and we repurposed it for our own task, which is llamas and T-Rex. So what is actually happening is it's forgetting those thousands of classes that it was originally trained on and repurposed to only identify between our llamas and our T-Rex inside there. Granted, it was able to basically do the training process significantly faster, right? Because it was building on top of the previous knowledge. Or it was using, not building on top, I gotta stop saying that. It's not building on top, but it was using the previous knowledge of that model. And so that's why it's called transfer learning, right? It's not called building on top learning, it's called transfer learning, where we're simply repurposing that model to a task that we want to do instead. If we want to be able for it to identify our llama, T-Rex, and its other thousands of images, then we're going to need to have it train those 1,000 images again. But the benefit though is that you don't have to train it as heavily, right? Because it already has all these existing patterns. So just something to take to note about transfer learning. So in the next section, we're going to officially talk about custom models. All right, so finally, we're going to be talking about the third way you can use machine learning, and this is through custom models. So custom models, right, the truth is that pre-trained models can solve all of your problems. There's going to be some cases where you have your own unique case that you need to solve, and as a result, you're going to need to create your own model from scratch. And so we're going to see how we can do that with ml5.js. So this is what we're going to be building, a student score predictions, where it's basically going to take the amount of hours a student has studied per week, their attendance, and their school exam scores, and it's going to produce some sort of numbers. So if I were to refresh this, you're going to soon see that we have this interesting graph. And this right here is essentially the loss value that I talked about. But what we're going to see is this concept called epoch, which I'll talk about later, but it's essentially the amount of times that you study the data set. And as we go through epoch higher, you're going to see that the loss value decreases. And so what this app does now is that I can put some random values. So let's say that I study like 20 hours per week, and I have a 90% attendance percentage, and then I had an 89 in my last score. So if I predicted, it's saying that my state exam score would most likely be a 97.84%, which is pretty damn good. So let's see how we're going to build this, and we'll talk a little bit more of some of the concepts that we just saw from that graph. So I'll see you guys in the next one. Okay, so let's start talking about this code inside here. So you should be inside the neural network basic, and what you're going to notice is that we're using the latest ml5.js project inside here. So if you remember the demo, it's really just a bunch of form inputs. So we got our hour study per week, we got our attendance percentage, our school exam scores, and then we finally have our button to predict the score, which returns the predicted exam or the state exam scores. So inside our script.js, the first thing you're going to notice is essentially this big long data set. And yes, it's all fake data that I inputted myself, but eventually once we're done with this, I'm going to show you how we can get practical data from Kaggle's data set. And then right here, we finally have our function predict scores, which is going to be triggered by that button, which is going to do our actual classification, which we haven't made yet. So let's get started. So the first thing you're going to notice, this is ml5 set backend WebGL. WebGL is typically known for setting graphics inside the browsers, but for our case, it's really just there to, it's really a requirement to work with the neural network in ml5's like newest version. But a lot of it really comes down to optimizing our computations. And to really just use our GPUs. And because the thing is with neural networks, it's very computational intensive, and so this essentially is a way for us to make that computation a lot more efficient. Okay, so anyway, just make sure you add that. And so for step number 2, what we're going to do is we're going to be setting up our neural networks inside. So what I'm going to do is, just for analogy purposes, I'm just going to say brain, and I'm going to say neural network. And essentially what we're going to do here is we're going to define our purpose. So there's two ways you can put this. There's classification and then there's regression. So classification is whenever you're trying to find a discrete label, which is what we've been doing with the images and everything. But in our case, because we're trying to find a continuous value, that is known as a regression problem. So a continuous value. And then we're going to set debug to true. And the reason is because it's going to show us that nice graphics, right, of how our loss value is showing as each patch is happening. Next, we have our data set. And this is in some ways like us creating the flashcards. So I'm going to say data.forEach. And I'm going to have each of these items displayed. So we're going to have an input. So the input features. And then we're going to have our output. So as our input, we're going to add some of the features that we want to pay attention to, right? So remember how I talked about the different types of features that's out there, right? So we're going to have the hour studied, items.hour studied like so. Then we're going to have our attendance, items.attendance like so. And then we have our school exam scores, which is items.school exam scores. And then finally for our output, this is basically going to be the answer that we're trying to guess. This is going to be the state exam scores. Item.state exam scores. So you can imagine that in some way we're basically kind of creating some flashcards. We're writing the features, remember, in the front of the cards, and then we're writing the output of it. And this is just going to simply look like this. It's going to say brain.add data, input, and finally output, like so. Step number 4 is normalizing the data. So the thing about this, hour studied and attendance and school exam scores is that they all fall in various different types of ranges. Like hour study could be anywhere from 0 to 1,000. Attendance can go anywhere from 0 to hundreds. And let's say in this case, school exam scores can go anywhere from 0 to 200. In those type of cases, right, you can see that the ranges are all variously different. And what we want to do is we want to make sure that they're all in the same range, so it's a lot more easier to calculate. For example, from a range of 0 to 1. And so this actually is very important in training whenever you're training machine learning models. And there's a very simple way that ML5 provides us to do that. And all we have to say is normalize data, like so. And then finally comes the actual training process. We say brain.train. And we need to actually define some options of how the training is going to look like. So I have training options like so. And one of the things you're going to notice is this thing called epochs that I talked about a little bit briefly in the demo. But epoch is basically the amount of times you study the data set. So for example, in this array, we have like 24 items in the data set. If I study all of this once, that is 1 epoch. If I study it twice, that is 2 epochs. So it's the amount of times you're studying the data sets. And I'll just put arbitrary number of 32. And then we're going to have something called batch size, which is essentially the amount of data that you're looking simultaneously or looking at the same time for each time that you're studying it. So, sorry, I complicated that. But basically what I mean is that, like, for example, we have 24 items in the array. If I set it to a value of 12, that means I'm basically setting it 12 data at the same time, and then another set of 12 datas, and that basically completes epoch, right? Because 24 divided by 12 is 2. So with this batch size, it's going to allow us to do 2 batch size to complete 1 epoch. And so right now, these are arbitrary numbers, and really whenever you're training machine learning custom models, a lot of it really just comes down to just experimenting with these values. A lot of people have this interpretation that, oh, if I have a higher epoch, that means that for sure, because I'm training it longer, there's going to be a higher accuracy. And that's true to an extent, right? But the problem is that you're going to be falling into a problem called overfitting. And so the idea is that, like, if you study like something too much, at this point you're not really learning it, you're basically just memorizing the answers. And so this could really happen in these models where it just knows the data so well, memorizes it, that immediately whenever you give it like a data or validation data, right, it's going to get it completely wrong because it doesn't actually memorize that type of answer. And same goes to batch size as well too. A lot of people have this interpretation that if you have like a smaller batch size, it means that you get to pay more attention to details to these data. But that's often not the case. You have to experiment with these values. But a good tip in general is that, like, you always want to split your training data with your validation data, so you can ensure that there's actually accuracy happening with both of the models and it's not overfitting or underfitting. So anyway, I basically set the training options. These are something you're going to experiment with, but I just set it for 32 for epoch and 12 for batch size in the meantime. I'm going to put training options inside here, and then I have a callback function, which I don't have right now, called finish training. I'm just going to say function finish training, and I'm just going to make it very simple, where I'm just going to console.log model training finish. And that's it. We add our data. We create neural networks. We add our data. So in some way, we create our flashcards. We normalize the range for easier computations. We do our training and set the configuration for it. And then finally, what we have here is the actual prediction process. So what I'm going to do inside here is I'm going to just simply say brain.predict. And then remember, it's going to take in input. So remember, it's going to look at these values inside here, the flashcards. Remember how we had different features. It's going to look at the inputs, and then it's going to return the output, which is going to look like this results inside here. And all we're going to do with this results is we're going to say document.getElementById. We want to output it in the HTML. So what I'm going to just simply say is that, and then text content. And then it's going to be results 0. And then we're going to have a dot value to fix. So it's 2 decimals. And it looks slightly different from what we're used to. We didn't use the dot value before, we did dot label, but I'll show you why, because it's just designed a little bit differently since this is a regression problem. So now if we were to test this, I can open it in live server. You're going to see that immediately we start training, and so it goes up to 32, right? And notice how basically it reduces it as we do longer the training. Remember, you want to experiment with this with actual validation data as well too, to ensure that you're not just memorizing and answering, you're not overfitting. Okay, so now that we have that established, now if I were to close this little sucker, oh, and also I'll show you the answers of that thing we're going to console. So I'm going to basically say, let's say I studied for 20 hours and my attendance is pretty accurate, 90%, and I got a school exam scores of 95. Well, my predicted score is going to be 97.82. And you can see over here that because it's a regression problem, the data looks a little bit different. But instead, we basically have the value that we want to output inside there. And you can see we took the first 2 decimal points inside. So yeah, that's essentially how you can work on a custom models. So in the next one, we're going to basically look into getting a data set from Kaggle so we can add some more practicality to this. So I'll see you guys in the next one. All right, so I'm going to show you this website called Kaggle, which is a cool website that has a repository of a bunch of different types of data sets, which are real data sets that you can incorporate into your projects. And you also have models as well that is already pre-trained that you can leverage as well too. So the data set that caught my attention is the student grade prediction. And it's pretty simple. It provides like basic information of the person's gender, the age, the address, the family size, and so on. And so what I did in order to incorporate this is the first thing I did is I downloaded this. And then I just basically extracted all of that out to my downloads files. And then all I did is I went to my CSV, chose a file. No, I don't want llamas. And I'm going to take this stuff like so, convert this, and then I basically download the data.json. And so once you kind of already have that downloaded, I think you kind of expect what the pattern is going to look like. So I didn't put it into practice because it's basically the same thing as the neural network basic, so we're just using a different type of file. So in the advanced ones, what you're going to notice is that inside here, that data.json is basically this thing that I just downloaded just now. And then I'm just incorporating that to the project. So in the index.html, remember, all you have to do is basically add those additional values that this input is looking out for. And you also have to make sure you add it as well too. So it's just basically adding more properties. But you can notice that the idea is very similar, right? Like all you're really doing is you add your neural networks, right? Then you add your data like so. And then you normalize your data, then you do your training options, you train the models, and then you finally do your predictions. So the idea falls to the same exact idea as well. So yeah, I would just say just experiment and just play around. Like you don't have to do student grades. Like you can do other things like plant diseases, for example, as well, and just define certain features, whether that's classification or regression problems that you're trying to solve. And so the last thing I want to talk about is how you can actually save your models as well too. So in order to save your models, what we're going to do is and I think I could use this as an example, right? So the moment whenever we actually finish our training, one thing that you could add is this thing called brain.save. And brain.save basically does is once it finishes doing the training process, it's just going to download the model so you can use it for future references. And so, for example, if I were to run this application, you're going to see that it immediately downloads all the files after it finishes this training. And yeah, I'll allow that. Give me a second, I have to refresh this. Oh, God. Right now, it's doing it not so hot. But yeah, I don't know what's happening right now. I had to refresh it because I don't know if it was something of a bug. But yeah, basically you can see over here that it is under 0.06. I don't know why it stayed in one line, but I guess it happens. But the basic idea that I want to talk about is that you're going to notice that we have all these files inside here. And you know, I tested this multiple times when I played around with this. But remember how I said you have your model.json, which talks about the model architecture. You have your model weights, which is the weights that was adjusted during the training process. And then you have your model meta, which basically is just metadata about your models. And then you could just simply take that code and you can incorporate it to your project. So I'll give you an example that you can look at later on. But I have the save model where essentially if I go over to the script.js, remember how we had to do all that process of like adding the data, and then we had to train the data and so on, and then we finally got to use it. Well, we can skip all of that, right? We create the neural network like so, and now what I can do is I can import that model that I just downloaded it. So I can take the model JSON, the model meta.json, the model.weight.bin, and then basically just load that inside there with the model info, and then immediately you can see I skip all of that. I could just jump in straight into the actual prediction process. So that's basically one way to do it. So just to kind of summarize inside here, you can see in my script.js, I just simply add the save like so, and I can comment that out now since that's been completed. And then I could just simply go into my project and just create a folder called model, import the projects or the files inside there, and then basically just simply load that model and then immediately start using this without having to get all the data and doing all the training. So yeah, that's basically a way that you can incorporate actual data into your projects, and then you can save it for future usage. So anyway, that's basically all there. That's basically the different types of ways you can incorporate machine learning to your projects. So what we just talked about just now is ways that you can use teachable machines and how the training process looks like. So we talked about pre-trained models. We talked about transfer learning in order to build or to basically use existing models' knowledge. And then we talked about neural networks where we could build our own custom models if the pre-trained model wasn't accustomed to our own problems and we needed to have more of a custom problem for ourselves. So yes, I think in the next session, I'll do a nice summary, and I'll see you guys in the next one. Oh, okay, if you're watching this, we finally have made it to the end. And yeah, hopefully by the end of this, you guys have a better understanding of like the components of machine learning, which is the data, the training, and the models, and that makes a prediction. And then you understand a little bit better what actually happens during the training process and how we talk about things like the features and the weights and the epoch and batch size that go into a neural network, for example. We also talked about the various ways of how you can actually use machine learning, which is with pre-trained models and transfer learning, and then finally making our own custom models as well too. And so again, this is really just to give you guys enough knowledge just to be curious. And I know it's an intimidating subject, but you know, really go explore yourself and read the ml5.js documentation. And you know, if you have a good feel for that, I challenge you to check out the TensorFlow.js documentation as well, which is maybe something I can make a tutorial on later on. But anyway, congratulations. It was nice working with you all, and I wish you guys the best of luck. Bye-bye.